Okay, I am a graduate student at the Department of Mathematics. I teach Math 147 honors. I don't teach Math 125, but I always volunteer for the reviews. So you might have seen me before. Anyone have seen me before here? Yeah, you saw me. Okay, so today I'm going to take our entire 2 hours for the reviews, because I'm taking for Joseph Brennan also. So 2 hours is a long, time. So hope we have fun. Okay, the first problems. Let's, get back to the math. The first problem, like most of your exam, I think 75% will be about the derivatives and 25 will be on the integration. The first thing is, first and foremost thing they ask us to use the definition of derivative to calculate the derivatives. So at this point, you know how to compute the derivative of this function easily, by using the power rule. But we want to here avoid the power rule and we want to develop the derivative of this function by using the definition. So the first thing I'm going to ask you, what is the definition of the derivative? What is the f prime of x? So we can write the derivative, definition of derivative in term of limit. Limit h approaches to 0. F x plus h minus f x divided by h. So derivative is nothing but is the limit of a quotient f x plus h minus f of x divided by h. And this quotient, if you look at this quotient, if I take h goes to 0, this quotient is an indeterminate form, 0 over 0 form. So when I plug f into this, what I need to do is I need to simplify. I need to remove the singularity because this is a 0 over 0 form. I somehow need to simplify in a way that I can remove the singularity and get the limit. Okay, so what is my function here? F of x is x square minus x whole raised to power negative 1. And this also can be written as 1 over x square minus x. Is that okay? So if the exponent is negative, we can remove the factor in the denominator. Okay, let's now compute this quotient first. First goal is to simplify this quotient because this quotient has the singularity. It has a 0 over 0 form. So let's compute f x plus h minus f of x. So I'm going to compute this term first and then I divide by h and then I will simplify to the point where I sort of remove everything which is a bad. So what is a f x plus h? You're going to take x as a placeholder and place x plus h. So this is a 1 over x plus h, the square of this, minus x plus h. This is the value of your f x plus h. F x plus h will turn into 1 over x plus h square minus x plus h. Because x was the placeholder, I placed the value x plus h in that placeholder. Minus f of x, I can just put that term here. Now, we need to simplify this one. How we can simplify such a thing? If you have two quotient, one quotient is subtract from the other quotient or you add two quotient. In order to simplify these quotient, what you need to do is you need to make the same denominator. You cannot add or subtract the quotient until or unless your denominator is same. So if you want to make the same denominator, what you need to do here is, what you need to do here, let me put that parenthesis here first. I will multiply this term by this x plus h square minus x plus h, and I will multiply this term x square minus x. Then my denominator will be same. So whatever was not in this factor, I multiply there, and what was like lacking of this one, I multiply that term. Since I multiply something in the denominator, I have to multiply that thing in the top also. So x plus h square minus x plus h. And same thing I have to do it here, x square minus x. This is the main step of the quotient, how to simplify the two quotient by making the same denominator. Now it's look a bit ugly because denominator is a big factor, but in mathematics, be always patient, you know. So that's what we teach in math. So now what is the common denominator here is x square minus x, okay? And this is a x plus h square minus x plus h. Is that okay? Anyone have any doubt? Let's see what is the top. Top is x square minus x minus, I can FOIL this thing. You know, I can FOIL this thing with the parenthesis. Inside the parenthesis, x square plus 2xh plus h square minus x minus h. Anyone have any objection here? But I didn't do anything. I just, first term as it is. Second term, I FOIL the square of x plus h. By using the formula a plus b, square of a plus b is the square of a plus 2 times ab plus the square of b. Now, we'll see that. Is there anything will cancel out? This term cancel out this. This will cancel this one. Is that okay? Okay, now let's write down what left on the top. Minus 2xh plus h square minus h square. Minus minus plus h. Whole thing is divided by x square minus x plus h square minus x plus h. Anything here which is not clear? Okay. One thing I can do more is I can pull out h. If I pull out h, is going to be minus 2x minus h square plus 1. Whole thing is divided by that monster, which is x minus x, and parentheses x plus h square minus x plus h. Now, if I divide the entire term, x plus h, this factor minus f of x, whole thing is divided by h, what is going to happen? This h going to cancel with that h. No? And I'm going to left with minus 2x minus x square plus 1, whole entire thing is divided by x square minus x, parentheses x plus h square minus x plus h. How about this? Okay, yes. Oh yes, there's only one h left. Yeah, you're right. Excellent. At the end of the day, it's not going to matter, but still, it's mathematically not correct. Now, if I take the limit, now f prime of x is nothing but is the limit as h goes to infinity, h goes to 0 of minus 2x minus h plus 1, whole thing is divided by x square minus x plus h square minus x plus h. Okay, so the limit is nothing but this is the limit of that quotient which is simplified. Now you can see if I take h goes to 0, there is no singularity. There is no 0 over 0 form. I will get the clean answer. So what will be on the top? It will be 2x plus 1, and what will be the bottom? Bottom will be x square minus x and x square minus x. Is that clear? Okay, let's go back again. So see what we did. The first thing is we need to know is what is the definition of the derivative. So this is the first case we sort of know. So derivative of the function in term of the limit is the limit of that quotient, which x plus h minus x divided by h. So what I did, my function was x square minus x raised to power negative 1. I write this function in a better form, 1 over x square minus x. Then I plug this function here. I insert this function here, and I need to simplify that quotient. In order to simplify the quotient, I need to make the same denominator. So I add this term here, and I add this term on the top and bottom, so they cancel out to 1. I add this term here, and I add this term on the top and bottom, so they cancel out to 1. So I get back what I had before. Now, I have the same denominator. I can add the top or subtract the top, whatever the sign is here. So you see, x square minus x minus that whole entire thing. So this I can FOIL x plus h square. If you can write x plus h and FOIL it out, you will get x square plus 2xh plus h square minus x minus h. This will cancel this will cancel this, you will left with this. But you have to divide it by h. So I divide the whole entire factor by h. So this h goes cancel out. So I left with this term. And now I can take h goes to 0. Once I take h goes to 0, it means I plug h is equal to 0 in my quotient, and I get my derivatives. They ask you one more thing. They ask you compute this derivative. Let me put that thing on my name. Okay, so how it goes? That's good enough. Next thing they want you to compute is what is the derivative at x is equal to 3. So you want to compute the derivative at x is equal to 3. So what you just do is you take the derivative, which is equal to minus 2, you plug 3 there, plus 1, God, what is that thing? X square, 3 square is a 9 minus 3, and that's the whole square of that, because this is the same term. Minus 6 plus 1 is minus 5, and what is 6 square is a 36. Yeah. So that is your answer. Another thing they want to do is verify, use the rule to verify your result. Let's say that the calculation we did was correct or not. So f of x is equal to x square minus x raised to power negative 1. We're going to use the power rule with the quotient rule, or the chain rule. You guys know what is the chain rule, Chain rule is if f of x has some power n, I'm going to give you the chain rule in terms of power. Then you take the power down, you take 1 from the power, and then you multiply the derivative of inside, f prime of x. How about this? We're going to use the same rule here. I take the power down, so 1. I take 1 from the power, that's 2. 1 minus 1 is 2. And then I multiply the derivative, inside derivative, which is a 2x minus 1. Okay? If you don't think this term is equal to that term which I computed doing a lot of calculation. So this is going to be minus 1, 2x minus 1. Whole thing is divided by x square minus x to the whole square, which is the same as x square minus x to the whole square. So my both result match. So that solidate our answer. Always verify your answer by using the actual derivatives, because actual derivative is easy to compute than using the definition. But all the derivatives are coming from the definition of the derivatives. Any question? You see this term, basically x square minus x to the power negative 2. I move that term to the denominator. So you can bring that term in the denominator if the exponent is a negative. And you can do the same thing. If something is in the denominator, you can bring it in the top by switching the exponent. That's the one of the rule in Math 101. Okay, so one problem is done. Let's move to the second one. What do you think second problem is asking us? And find both points on the curve. So it means there are 2 points on the curve. Example number 1b. So I always have an issue of understanding Brennan English. Okay, but this one is not bad. F of x is equal to 2x minus x square. They say there is some graph of this function. Let's suppose this is a graph of the function. And there is a point. Point is 1 and 10. If you draw a line which is a tangent to that graph, you want to find this point. Let's say this point is a comma b. Let's say that point is a comma b. At this point, I assume that there is only one point, but you will see that it turned out to be there is another point on the curve. Okay? But at this moment, I can assume that I want to find the equation, I want to find the point. See, if I draw a line which is a tangent to the curve, meet this point at this, meet the function at this point, x is equal to a, y is equal to b. So one thing is immediately clear. If this point is on the graph of the function, then b is equal to 2a minus a square. Anyone have any doubt about this? B is going to be is equal to 2a minus a square, because a comma b going to satisfy the equation of the function. The equation of the function is y is equal to 2x minus x square. So you plug x is equal to a and y is equal to b here, and you get this equation. And keep that equation in mind, we will use very soon. Now, I have a two way to compute the slope of this line. One is using the slope intercept form, and one is using the derivative. So there are two different ways to compute a slope of a line. If you have 2 points, you can use the slope intercept form. And if you have just 1 point and you want to find the slope of the line, so you just compute the derivative. But in that situation, you need the function. So let's see what is the slope of in first situation. The slope of the line is b minus 10 divided by a minus 1. That's the slope of the line. So what is a b? b is equal to 2a minus a square minus 10 is equal to a minus 1. I just want to everything into one sort of variable, so I plug that b. The b I evaluated in the very first equation, I plug that equation into the slope of the line. Another way to computing the slope is, this is the same number, m is equal to the derivative of the function evaluated at a, evaluated at the x exponent of the function, exponent of the point. So derivative of the function evaluated at the x exponent of the point. What is the derivative of the function if you differentiate? Anyone? Your output is precious. What is the derivative of this function? Going to be 2 minus 2x. Good. If I plug a here, it's going to be 2 minus 2 times of a. Is that okay? So these are the same number. Let's suppose this is equation number 2, this is equation number 3. So 2 and 3 implies 2 and 3 will gives you 2a minus a square minus 10, whole entire thing is divided by a minus 1 is equal to 2 minus 2a. Now we have a equation in a. So we have equation in a. I think we can solve this equation in a. How are we going to solve this equation actually? Anyone want to give me an idea? what we should do when we want to solve the equation. First thing is you clear off the denominator. Denominator are not good candidates, so we're going to kill them. So first is, if I want to clear off the denominator, I will multiply both sides by x minus a, or I move that x minus a on this side. Okay. This is going to be 2a minus a square minus 10 is equal to 2 minus 2a multiplied by a minus 1. Because I want to find a quadratic equations in a, so I will FOIL this thing out. This is going to be 2a minus 2 minus 2a square plus 2a. And that's going to be 2a minus a square minus 10. I just FOIL this thing out and trying to simplify as much as I can. Okay, let's move everything on one side. I'm going to move everything on this side. So if I move 2a, so this is a 2a, and that is the a square. If I add 2a on both sides, I'm going to get a square. So this plus this is a 4, and that is a 2. So 4, if I subtract 4, I'm going to get minus 2a. And this is a 10. If I move that one, I add 10, it's going to get 8 is equal to 0. We're going to factor that equation. So a is equal to 0. What are the two numbers which multiply to 8 and add to 2? Is there any number who multiply to add? 4 and 2? 4 and 2. Is that okay? They multiply to 8, and if you add them, you get a negative 2. Therefore, a is going to be equal to 4, and a is going to be equal to negative 2. So these are the 2 x exponent of the point whose line passes through that point, is tangent to this point. So what are the point actually? So point is this. If you choose 4, if you plug 4 here in your function, what do you get? 4 times 2, 8. 8 minus 16, minus 8. So this is the one point, and another point, let's say this point A. What is the point B? Minus 2. If you plug minus 2, minus 4 and minus 4, minus 8. Yeah. So it means there was another point here also. The line was tangent to that. Okay. Again, one more time, if you want. Okay, so next question is asking what? Find the horizontal asymptotes. So asymptote, there are two types of asymptote. One is the verticals, another is the horizontal. Verticals are easier to compute. You're going to just put the denominator is equal to 0 and simplify if, whatever the denominator is. Horizontal asymptotes are sort of linked with the definition of limit. It linked with limits. So exam 1C. So he said, Brendan said this question was in exam 1 and it was a C somewhere. So what is the definition of horizontal asymptote? Anyone can tell me horizontal asymptote, ASY. Okay, so definition is this. Y is equal to limit x approaches to plus minus infinity f of x. Okay, this is you're going to put in your memory tomorrow or Thursday. You may need that definition. Is that okay? The limit y is equal to limit x approaches to either plus infinity or minus infinity. There are two limits, I'm going to compute simultaneously because there are not much difference between them. You will see. There are going to be minor difference. I will let you know where. Of the function f. So we're going to compute the limit of the function f. Let's see what my function is. So it's going to be the limit x approaches to plus minus infinity. What is my function f? Wow, that is not look nice. So x square plus x minus x. The one thing is I can just try to plug infinity in the function and see what happens, you know. So let's see, if I plug infinity, let's say if I plug positive infinity, plus infinity. Infinity square is infinity, and plus infinity is again infinity, and the square root of infinity is again infinity. So this whole term is infinity. Then minus, this is also infinity. So minus infinity. But we don't know which infinity is bigger and which infinity is smaller. So we wouldn't be able to get a number. So what this form is called? This form is called indeterminate. You cannot make any decision which infinity is bigger than, you know, which. You cannot compute, like if it is an ocean, you cannot say this ocean is bigger than that ocean. Until or unless you go one day and you try to calculate the volume of the ocean. I highly suggest against it. Okay, so if this limit is indeterminate form, what we can do is we try to resolve that indeterminate form. By what? By calculation, by simplification. If you want to simplify something like this, you have to use this property which is called a plus b multiply to its conjugate a minus b is going to be a square minus b square. So this is a magical equality. We say a plus b times it is conjugate a minus b is nothing but this is equal to a square minus b square. And you can verify this easily, you know. So just FOIL this thing out, you multiply this to this, you multiply this to that, you multiply this to this to this. A, b gonna cancel out, you're gonna get a square minus b square. Okay? Let's see, we're going to use this one. Limit x approaches to plus minus infinity, x square plus x minus x, and I'm going to multiply by its conjugate. The conjugate of this is x square plus x, and I'm going to divide by conjugate because something is multiplied has to be divided in division also so that I can balance the equation. You know, otherwise there won't be a balance. You multiply something in the top, you have to multiply that thing in the bottom. That is the rule of law in mathematics, okay? Okay, wow. Now, so you see x, a minus b, a plus b, these are conjugate to each other. I can use this formula. So this will be limit x approaches to plus minus infinity, square of this, x square plus x, the square root and the square of this, and you know what is going to be this, and then x square, and then whole entire thing in the denominator, x square plus 1 plus, x square plus x, x square plus x, x square plus x. Okay? What do you think about the denominator? Is anything is going to happen in the denominator? So this is a limit x approaches to plus minus infinity. This is going to be x square plus x minus x square. Square and square root, they do not like each other, so they cancel. Plus x. And x square gonna cancel with x square. Is that clear? Okay. One more step, maybe I would write here. Limit as x approaches to plus minus infinity, this is going to be x over square root of x square plus x plus x. This is still an indeterminate form. If I plug infinity, I'm going to get infinity on the top, infinity on the bottom. So there is still singularities in my quotient. But I can factor this quotient somehow. I can factor this in singularity. If I pull out x from this term, I'm going to get 1 x plus, no. If I factor out x square from here, I'm going to get 1 plus 1 over x, and that's plus x, and top has x. Okay. So this is x square. The square root of that is going to be only single x. So limit x approaches to plus minus infinity. This is x divided by x. I can pull this thing out. It's going to be 1 plus 1 over x plus 1 because I pull the x out. And that x cancel with this x. So the limit x approaches to plus minus infinity. This is going to be limit x approaches to plus minus infinity. I'm going to write one more time, and this is going to be the one last time. 1 plus 1 over x plus 1. Now is the punchline. If x goes to infinity, let's say x goes to positive infinity, 1 over x goes to positive 0. It will go to a positive 0. It will approach the 0 from the positive side. So if x goes to positive infinity, this quotient is going to be 1 over 1 plus 1 because this term is 0. And what if x goes to minus infinity? You are approaching to negative 0. 1 minus negative 0 plus 1. What is going to happen? It's going to gain 1 plus 1. Yeah, one time my student asked me what is the difference between 0 and positive 0 and negative 0. I said quit. I was in India. So there is no difference between 0 and minus 0, okay? Next is use the intermediate value theorem. What is the intermediate value theorem? Use the intermediate value theorem to do what? To show that this equation has a root. The first thing is, it's very difficult to say this equation has a root, It's difficult to compute this equation as a root because it's a fourth degree equation. If you have a quadratic equation, it's easier to compute. You have cubic equation, you need a calculator. If you have fourth degree equation, you need a computer, So, but today we're going to sort of compute the root of the fourth degree equation without using the calculator. Exam. Brennan said this is in exam 1D. What does mean actually that? It means in 1 and number D. Okay. The function is f of x, x to the power 4 minus 8 x plus 3. What the intermediate value theorem say, if the function is at A, is value, let's suppose is a positive, and the value of the function at another point B is a negative, or other way around. If the value of the function at one point is positive and at another point is negative, or other way around, means negative first and then positive. If they have alternative values, the sign at point A and B, then the intermediate value theorem, IVT theorem, will tell you there exists a point C in between the interval A and B. At this point, the function will have a 0. That will be the root of the function. So this is very short form of the intermediate value theorem is, if you find a point, the value of the function is positive, and you find another point, at that the value of the function is negative. If they have alternative sign on 2 points, there is going to be a third point in between somewhere, but we don't know the exact location of the point. But there is going to be a third point where the function going to goes to 0. It has going to 0 value. Let's see if we can find such a point. So we're going to hit and trial. Let's plug 0. 0 is easier number to start with. I will get 3. Yeah. If I plug 0, 0 to the 4th is 0, minus 8 times 0 is 0. So this is a 0 plus 3. Doesn't matter what is a negative 0 or positive, it's going to be still plus 3. And how about 1? 1 to the power 4 is 1 minus 8 plus 3. 1 minus 8 plus 3. That's the negative. What number? 4? Wow. That means the intermediate value theorem will tell you something. It means intermediate will tell you by intermediate value theorem, by IVT, there exists a C, such C, which is such that C is between 0 and can be on like 1 and 3. So C is between 0 and 1 such that if I compute my function value at C, that will be 0. It means C is the root of my function. F of x is equal to x to the 4 minus 8x plus 3. Okay, so what next, Brennan? Apply the bisection method to obtain an interval of length 1/4 containing a root. Wow, okay. So they say they want this, the length of this interval which I found is 1. The length of this interval is 1. But they want you to short the length. They want the length of the interval 1/4, So I should have find some number which is less than that 1. But we're going to apply the bisection. How the bisection goes, you compute the midpoint of this for the next iteration. For C1, what I do, I go 0 plus 1 divided by 2. And that will gives you basically 1/2. I divide the interval into half. And now I compute what is the value of the function at C, or 1/2. Wow. What is a 1/2 to the power 4? 16? 1/16? Means 2 times 4, 1/16. Minus 1/2, that is a 4, plus 3. This is a 1/16 minus 1. That is a minus 15/16, which is a negative number. Is that clear? Okay, now at 1/2, the value is a negative, and at 0, the value is a positive. So it means next root will be between, so by intermediate value theorem, there will exist, I would say this is a midpoint, M. There will exist C1. Now it will be between, C1 will be between 0 and 1/2, such that f of C1 is equal to 0. Again, by intermediate value theorem. Now I have the interval of length 1/2, but I want to shrink this interval to 1/4. So one more iteration. Again compute the midpoint. Midpoint of this and this is going to be 1/4. 0 plus 1/2 divided by 2 is 1/4. Is that clear? Okay, now I'm going to compute my function value at 1/4. That's going to be difficult. Do you guys know what is the Siri? What is the 4th power of 4?
Here are some matches for power.
Okay, she didn't understand me. So it's going to be 256. I'm smarter than Siri. What is the 4 divided by, say, 2 plus 3? So this is 156 plus 1. That is definitely a positive number. That's a positive number. I use sometimes Siri as my secretary. I don't have a secretary, but I use it as I tell her I would think to do, book my appointment, buy my tickets, or remind me at least. Okay, now this number and that number has opposite sign. So my next root is going to be, therefore the next interval is going to be 1/4 and 1/2. Sorry, here 1/2. These are positive. So 1/2. And that is your answer, This is your answer. The next root is going to be between 1/4 and 1/2. And this interval has length 1/4. And that's what they want. Find a root. So there will be a root, there will be a root C2 between this, such that f of C2 is equal to 0. By intermediate value theorem. By IV theorem. Okay, I will do one more question, then we're gonna take a cry break. What happened? Wow. Should I take my statement back? Okay, so next question is sketch the graph of the function. So now I'm going to sketch the graph of the function. I will try my best to sketch a graph, but if it doesn't look like a graph, excuse me, but I will try my best. I hate these questions, by the way. Example 2.a. So let's see what information I have. The first, I know what is the domain of the function. You know, this is very important information. First, I need to know like what portion of the real line I'm going to plot my graph. You know, how big my canvas should be. What is the domain of the function? Anyone can tell me? Is there any point in the which is a troublesome to this function, which do not satisfy? We cannot? 5? No, that's okay. Function is, what is the function? The function is, if function is f of x is equal to x, 5 minus x to the power 2/3. If I plug 5, everything is 0. The value is 0. You want to find a point where the function does not make any sense. But I don't think there is any point which does not make any sense. You know, even the negative numbers are okay because you have 1/3. You know, 1/3 is fine with the negative numbers, but 1/2 and 1/4 and 1/6 are not fine. So your domain is minus infinity to plus infinity. That is the domain of your function. The second information which is coming from the second information on the question, this thing which is called a derivative. Where is this derivative? This one. What information the derivative will give you? It will give you one information. One thing is what it will tell you the function is increasing and decreasing. At what interval the function is increasing and on what interval the function is decreasing. So we're going to extract that information from the second information on the question. So for that, I think I need to do a line test. And what I need to do, I need to find what are the singularities. Singularities are the value of the function is 0. So one is a 5, another is a 3. You know, these are the critical values of the function, the derivative of the function, critical values of the derivative, or you know, whatever you call it. So derivative is, if I pull out 5, you know, that will be easy. This is a 3 minus x, and that is a 3, 5 minus x. One thing to be noticed, the derivative is not defined at x is equal to 5. So it means the function is not going to be smooth at x is equal to 5. It's going to have some cusp or some corner at 5. You know, so one information gives you, so there is a corner as it is 5. You know, it's going to have a corner. Okay, so if I plug any number between 3 and 5, what is the number between 3 and 4? If I plug 4 here, so that give me negative. If I plug 4 here, that give me positive. So the entire gonna be negative, you know. How about if I plug 0 in the function? So this is going to be positive, this is going to be positive. I'm gonna have a positive here. And if I plug 6, so this is going to be negative, this is going to be negative, negative, negative is positive. Yes, my blood group. Function is increasing here, function is decreasing here, and function is again increasing here. That information is going to give us, the derivative of the function is going to give us this information. The function is going to be increasing from minus infinity to 3. Then it's going to start decreasing from 3 to 5, and then it's going to start increasing from 5 to infinity. So these are the informations we will use to plot the function. The bullet 3, because we have one more information which is about the second derivative. Now I'm going to ask you again, this is the second derivative of the function. What kind of information about the function we can extract from the second derivative? Can cavity, cave, upward, cave, downward. Raise your hand if you are going to cave tonight. Are you going to cave tonight? No? Please don't forget to bring your fake IDs there. No, that's very important, reminder. So this is a 10x minus 6 divided by, so we're going to compute the concavity. You can compute using the second derivative. So let's do the line test again here. How many critical values we have? We have the critical value x is equal to 6, and then we have critical value x is equal to 5. And why 3? No, we don't need 3. We need the critical values of the second derivative. We don't need the critical value which is before, the critical values was. So I'm going to look for the critical value of the second derivative. That's why I call the critical value of the second derivative, critical value of the first derivatives, critical value of the function. But sometime book called the critical value of the derivative, they call the critical value of the function. Okay, but this is just a terminology. If I plug a number which is a less than 5, which is 0 in my second derivative, what I will get? Zeros, minus on the top, plus on the bottom. So the sign is going to be negative here. They sometimes say n negative. What is a number between 5 and 6? 5.5. If I plug 5.5 here, this is a negative. If I plug 5.5 here, this is a negative. So both are negative. 5.5 negative here. But this thing has a fourth degree. It's a square of something. So that negative sign doesn't matter. It's always going to be a positive. Did I ignore the last time? So this is, if I plug 0, this is a negative. If I plug 0, yeah, this is a negative. That's fine. Because if I plug 0 here, that is a negative 6, but if I plug 0 here, that's a positive. But if I plug 5.5, this is a negative, but the square of that number is a positive. So this is a number is again going to be a negative. Any objection? How about if I plug 6? So this is going to be a positive then. Because this number is always stay positive. It means the function is going to be concave down over that interval and is going to be concave up over that interval. Okay, so now I'm going to take a real line and draw the actual graph of the function. So the function is increasing. So there are three things. First thing is the function is passing through region. So this is the origin. Function is passing through region. But function is increasing till point 3. So if this is a 3, the function is keep increasing. And then function started decreasing till point 5. So this is a 5. The function start decreasing. And the function has some sort of corner at 5. And then function start increasing from 5 to 6. But it's still 5 to 6 still downward, and then it's become upward. It's like that. The minor point of inflection is at 6. 6 is the point of inflection. Any question? Yeah, that's a bit, you have to keep all three information one time at your mind in order to plot this function. So, but you have to go by one. First thing is find the domain of the function. We're going to look into the definition of the function and see if is there any point. Where is my calculator? Where is this thing? Okay, there you go. So first we're going to look into the function and we see that is there any point which is a critical. It means if you plug a point which does not make any sense. But there is no point. So the domain is going to be minus infinity to infinity. I'm going to plot the function over the entire line. Second thing, the derivative is going to give me the information about whether the function is increasing and on which interval the function is decreasing, which gives me the information by using this line test. So I see that minus infinity to 3, my function has a positive sign, derivative have a positive sign, so the function is increasing. From 5 to 3, it has a negative sign, so it's a decreasing. For 5 to infinity, it has a positive sign, and it is again increasing. The second derivative give you the information about the concavity, means the function is concave upward or the concave downward, again I will use the line test, the two critical value 5 and 6. 5 is sort of the point where the derivative doesn't exist, so it's a corner. But 6 is the point where you might have expect the point of inflection, where it will change the concavity. Again, I use the line test. I check that my derivative, second derivative, has a negative sign from minus infinity to 5. So keep sort of concave down till that point, and then it's a concave up. So it's a concave up from to the rest. Okay, so that is how we sort of plot the graph of the function. Oh, next question is calculate the derivative and limits. So this time we're now going to use the definition of the derivative. So we're going to compute the derivative using our rules of the derivatives. Should I do question number? I'm going to do question number 2, 1, and then I will leave you rest, because I don't think we can do all of them. We still have one hour. We want to do something about the integration. Exam 2b, question number 2b, if the function is x to the sine x. So you see that my function is the degree is not a constant. It is also a variable. So the function is function to the power function. So I don't think I have any rule. I don't have any rule of the derivative which I can resolve this issue. But one thing I know about this function, exponential function, and the logarithm function. One is a frog and another is a centipede. They live together, side by side. Sine of x. They cancel to 1, so they are inverse to each other. Sine, exponential function, and logarithm functions, they can cancel it, and I'm going to get back function x raised to power sine to the x. But this logarithm function has a property. This property is this. You're going to take the sine and put on the front. Okay? Now we need to know a rule, the rule of derivatives, and this rule is again called a chain rule. So I'm going to compute the derivative of the function f prime of x. Chain rule, chain rule, the derivative of the first function. What is the derivative of the exponential function? As it is, nothing change. The derivative of e to the x is a e to the x, and derivative of e to the f of x is e to the f of x. Times, this is again the turkey rule, one day. Again, time the derivative of inside function. So inside function is the product of two functions. So I will use the product rule. And chain rule, chain rule is, I already used the chain rule. I say the derivative of e to the x is e to the x, and then inside function stay as it is. And then I multiply the derivative of inside function, which is cosine of x times ln of x plus sine of x. What is the derivative of logarithm of x? Is 1 over x. And you are rocking your way to a solid data that. That's all. That's all. You don't have to simplify anything if you do not feel like simplifying. But if you want, then good luck. Okay. I can claim, I will do that, okay. I can claim this is again sine. I can write this function as it is, and this function is cosine of x. Okay, I will leave you question number 2 and 3. These are sort of the same. The second one is using the L'Hopital rule. The third one is using again the exponential function. How about we go to the question number? Question number 2c. At noon, so there is at noon, a ship is 6 miles south. South means, Georgia. And 8 miles west, which is the west side. Let me write down this one. Okay, never eat soggy waffle. That's how we remember. Never eat soggy waffle. A ship is 6 miles south. So this ship is here somewhere in Georgia. Very first time when I was in India, I really don't know any English. And then I came to Georgia. Guess what happened? Georgians speak terrible English. Their accent is, wow. I was struggling. Okay, 6 miles here, and then 8 miles here. And west, yes, 8 miles here at noon. So this is the location of the ship B. And what we want to do is, ship A is traveling east. Why is traveling east? Okay, so it's traveling in this direction. And ship B is traveling north. It's traveling this direction. Never heard this thing actually before. At what rate the distance between the ship changing at noon? So we want to see. So let's say this is my y, and let's say this is my x. And how about I make this origin here? Because I think this question is a bit confusing otherwise. Like suppose this is the point where I'm gonna measure my distance. Okay. So this is sort of my x distance, and this is my y distance. Okay. Yeah. So the ship A is traveling from suppose here, and it is at noon here, So this is like origin here, but this ship is here. And that ship is here and traveling in this direction. And this is the distance between these two ships. And Pythagoras' uncle has given a theorem, which is called Pythagorean theorem, which tell you if this distance is a d, so d square is equal to x square plus y square. Is that correct? Is that the theorem? The Pythagorean theorem, which tells you the hypotenuse square is equal to the square of the two sides. So x square plus y square. Okay, if this distance is changing with respect to time, I can differentiate this equation with respect to time. So let's see, if I differentiate this with respect to time, it's going to be 2d d dt. This is what I want. It's going to be 2x dx over dt. This is another thing I think I should have. 2y dy over dt. Wow, this is the differentiation. Now, let's see what information we have from the question. The ship A is traveling with 12 miles per hour. So this x is changing 12 meters per hour, Yeah. And this dy is traveling 15 miles per hour. So this is a 15. Okay. And let's see what is the x. X is, so y is a 6. And x is 8. Is that correct? Is there any other information I need? Let's see. 2 times, there are so many numbers I have to add now. 2 times 6 times 15. Is there anyone who have calculator who can add these numbers? So 2 times 8 times 12, 2 times 8 is 16, 16 times 12, I don't know. 2 times 6 is 12, 12 times 15, still I don't know. Anyone, calculator? Okay, 192, that's helpful. 2 times 6 times 15 is 30, 30 times 6, 80, 180? Wow, I'm so smart. What is the 192 plus 180? Come on, don't give up. Don't give up. Let me see. Siri, what is 192 plus 180?
It's 372.
Wow. 372. Okay, so, but what is a d? D is the distance, this square plus this square. So it means 8 square plus 16 square. So d is nothing, but this is equal to 8 square plus 6 square. You know, I think I should use another piece of paper. So it means, therefore, this is going to be 10. So 20 dt is going to be 372. This is equal to d over dt is going to be 372 divided by 20. What is the mile per hour? Yeah, this is the answer. The distance is changing with respect to time. 372 divided by 20, you can simplify to that a number, but I don't think we really need it. Okay, so any question here? Because this was all about ships and sailing, you know. The simple, you have to take the origins and then use the Pythagorean's theorem, and main thing is once you get your answer, when you get this equation, Pythagorean's equation, d square is equal to x square plus y square, you have to differentiate implicitly with respect to time. And if you do that, this is going to be differentiation of, this is going to be 2d dd over dt is equal to 2x dx over dt plus 2y dy over dt. Then you have to get all the information from the question, what is dx over dt, what is dy over dt, and plug it there and simplify with the help of calculator. And you get this number, 372, which is a divide by this 2d. 2d, d was 10, so 20, so divide by 20. Let's see what we have next. Wow, this is... Let's do the question number 2e. I'm going to skip some of them so we can get through the all. I think 2a is a bit relative to the exam, you know, because this is against the using the differentiation. So far what we have learning is the differentiation most of the time, how to compute the derivative. So the function g of x is a given, and this is x to the power 4 minus 2x square plus 3. And we want to compute what are the absolute max and absolute minimum of the function. So we want to compute what is the absolute max and absolute min, you know. So in order to do that, first I need to find the critical value of the function. So first I will compute the critical value, and then I have two critical value which is already given, the endpoint. Endpoints are always the critical value of the function if we are computing the absolute max and min. So I have two critical value here. I want to find all the critical value of this function which lies within that interval. Okay? And then we will do the test on all these critical values. Okay? So this is the scheme of the question. So in order to compute the critical value, I need to compute the derivative of this function. What is the derivative of this function? It's going to be 4x to the power 3 minus 4x. Derivative of 3 is 0 because it is a constant. If for critical value, I need to do is 4x to the power 3 minus 4x is equal to 0. I can factor 4x, it's going to be x square minus 1 is equal to 0. So x is equal to 0 and x is equal to 1 and minus 1. So these are the critical values of the function. Is that clear? You take the derivative, you set the derivative is equal to 0, you try to factor the equation. Once you factor it, each factor is equal to 0, will give you one critical values. There are three factors, x is equal to 0 and x is equal to plus 1, x is equal to minus 1. You set them, each is equal to 0. These are the three critical values. So now, three critical values, but the interval was -1, to 3, all these 3 critical values lies inside the interval or like on the boundary. So sort of all the critical values are valid. The first one is -1. The second critical value is 0, then it is a 1, and then it's a 3. We're going to do the test here. This is the test part of we're going to test these critical values. What we do is we plug these critical value directly into the function and see what happens. This is a different test than line test. Remember, you do not need to do the line test when you are computing the absolute min or absolute max. The line test is not valid for absolute things. The line test only can give you the bumps, like the local min or local max, which is the bump of the function, where the function has a little bit, bumps. Okay, again, we're going to try to see if we can do something without using the calculator. If I plug -1, so 1, -1, again, that's -2. So 1, 4 minus 2 is 2. And this is also 2. If I plug 0, this is a 3. That's going to be difficult. 3 to the power 4. 3 to the power 4, 81. Minus 3 to the power 2, 9, then 18. 18 plus 3. What that number is? What is it? 84 minus 1, 18. 12, 14, 6, and 7, 66. Is that correct? No? Yes? Okay, yes. Okay, which one is the largest number? I believe this is the largest number. This is your absolute maximum. Which is the smallest? There are 2 smallest, this and that. So these are the 2 absolute minimum. Okay, one more time. I can tell you what you need to do is basically, where is the question? Oh. So you have the function, you need to find the critical value of the function, you compute the derivative. This is a polynomial. Derivative is going to be just using the power rule. So 4x cubed minus 4x 2 minus 1 is 1. So derivative of 3 goes to 0. I plug this thing, set this thing is equal to 0, and I pull out the factor for x because I can. So once I pull out the factor 4x is equal to 0 will give me this, x square minus 1 is equal to 0, give me these 2 critical values. So I have 3 critical values. 3 critical value plus these 2 critical value, I have 1, 2, 3, 4 critical values now. 1 was repeated. Okay. I plug these critical value directly into the function, all of them, and I get these number. And now I choose which one is the bigger number and which is the smaller number. I find 66 is the biggest, so this is the absolute maximum. I find 2 their match, so this is absolute minimum. Absolute minima is -1 and -1. -1 and 1, and absolute maxima is 3. So there is a difference between the word maxima and maximum. Maxima is the x value, maximum is the function value. Okay, that's done. Should we do the cylinder one? You guys want to do the cylinder one? Okay, so let's do the cylinder one. Cylinder one is highly voted. A cylindrical can of volume 900 centimeter cube. Its volume is 9 centimeter cube. I need my Siri actually. What is, maybe you guys know, what is the volume of the cube? Cylinder. The formula for the volume of the cylinder, anyone know? Oh, okay, I think this is easy. Pi r square h. This is a 900 centimeter cube. The volume of the cylinder is pi r square h. This is equal to that. And I want to maximize my surface area. The cost is sort of related to the surface area, how much material you need in order to build the can. So this is going to be my surface area. What is the surface area? What is the formula for surface area? 2 pi r square plus 2 pi r h. Is that correct? I think it's correct, yeah. 2 pi r h, because 2 pi r, there are two circles, one bottom and one top. That's 2 pi r square each. And then the covered part is basically 2 pi r is the one side and h is the other side. So 2 pi r h. So what I want to do is, there are two different techniques doing this thing. So this is I want to maximize, and this is my constraints. I want to maximize this over that constraints. So one thing I can use the Lagrangian method of multiplier. Yes. Yes, we want to find the minimum of S. Minimum of S. We want to minimize the S subject that volume should be 900 centimeter cube. Okay. So we have a condition. You don't want, like, otherwise the minimum will be 0, you know, but you have a condition that you can sort of volume is that particular thing. So there are two different methods. Have you heard about Lagrangian method of multiplier? Okay, if you don't, that's fine. So what I will do that, I'm not going to use that method. I'm going to find h from here, which is going to be 900 divided by pi r square. And I'm going to plug that thing into here. Because I wouldn't be able to compute the maximum minimum if my function is not in one variable. If my function is in two variable, how I'm going to do that? You know, or is it not possible? Okay, so this is going to be 2 pi r square plus 2 pi r. What is my h? 900 pi r square. Anyone want to simplify with me? This going to cancel out. This at pi cancel out. Have you guys seen Life of Pi? That's a beautiful movie. Yeah. So 2 is 1800, and there is r in the denominator. Is that okay? After cancelling or killing everything, pi cancel out, 1 r cancel out, that's it. So this is my function in term of r only now. So if I want to find the minimum, I need to differentiate this function with respect to r, which is going to be 4 pi r minus 1800 divided by r square. Wow. You can know how I got the derivative of that function? You know how to get the derivative of this one? You use the quotient rule. You know, if you don't like familiar with the derivative 1 over minus x square, if you use the quotient rule, you get something like that. Or if you know what is the derivative of 1 over r, the derivative of 1 over r is a minus 1 over r square. So this is the derivative of that. This is the constant. Constant will stay as it is. If I set this thing is equal to 0, if I say my derivative is equal to 0, if this thing is equal to 0, what I get? I get 4r cube, 4 pi r cube minus 1800 is equal to 0. Is that okay? I just multiply by r square to kill the r in the denominator. You know, you can kill that r in the denominator because r is a positive. So I multiply by r square, so this will become r cube. That r go away, and that's 1800 is equal to 0. So what is your r then? So r is going to be 1 raised to power 1/3. There you go. So this is your r, and what is your h? H is going to be, I'm not going to simplify anything, you know, that's just too much for me today. Yeah, I like calculation, but sometimes it's too much. Or square 2/3, that's your h. This is the dimension of your cylinder. The cylinder should be of radius this Where is my thing? Should be of radius this and its height should be this. If you plug that thing in the calculator, you will get the answer in decimals and you can build the can. Okay, next. Just skip these. These are like, this one you have seen in your homework problem. Find the maximum length of the pole which is carried over. The equation of the line through, this one is, just don't do that one because this one is very calculation. Let's do some integration because this is the last half an hour. I want to do some integrations too because this is 25% of your exam is going to be, 25 or more is going to be also about the integration. But once you're going to go math 126 is all going to be about integrations. That's why math 126 is one of the most hardest math in KU. Because a lot of integrations. Integration is one of the most hard or difficult operations to do that. Certain things we don't have. We don't have product rule. We don't have quotient rule in integration. And there is another thing in the math 126 which is called a sequence. That is also not very nice. Okay, good luck for math 126 also because that is going to be a challenge for us. The first thing is prove basic integration. So basic integration, we don't really need to do integration. So number one, problem number one. So we want to prove this identity. We want to prove that if you integrate the function 1 over x from 4 to 6, your value of the integration always stay between 1/3 and 1/2. So what I notice here when I see that integration is 4 to 6, 1 over x dx. So it means x, these are the limit of x, That means x stay between 4 and 6. So the solution starts from here. So if x is between 4 and 6, if x is between 4 and 6, that implies 1 over x will be between 1/4 and 1/6. The inequality flipped. If you flipped the function, the inequality also flipped. So 1 over x, this is the function I need. This is the function I needed to integrate. This 1 over x. I needed this function to integrate. So what I did is basically see my x is from 4 to 6. So 1 over x will be 1/4 to 1/6. Let me rewrite this inequality. This is basically 1 over 6 less than is equal to 1 over x less than is equal to 1. And the integration of this 4 to 6, 1 over 6 dx will follow this inequality also. This is the rule. If f is less than g, the integration of f is also less than the integration of g. Because if some function is below another function, the area is also going to follow the same inequality. And this is going to 4 to 6, 1 over 4 dx. What is the integration of 1 over 6? I can integrate this function easily, but I don't know how to integrate 1 over x. I really don't want to integrate 1 over x even. Four to 6. If I plug upper minus lower, this is going to give me 2, 6 less than is equal to 4 to 6. And this is a 1 over x dx is equal to 1 over 4. That's going to be 2. Because 6 minus 4 is 2. Upper minus lower is going to give you this. And I believe 2 divided by 6 is a 1/3. 1 over x dx is equal to, this is a 1/2. That is what I want. That is exactly the things here. So I prove this thing, that the integration of 1 over x 4 to 6 is between 1/3 and 1/2. So the only thing is basically we need to look the very first one. the x is between 4 and 6 when you are integrating from 4 to 6. So then you use the reverse order of the inequality. So if you reciprocate this one, so you're going to have to switch the inequality. So you switch the side of the inequality, and then I just rewrite this inequality and integrate the whole entire thing from 6 to. These functions are easy to integrate. This function is easy to integrate. I don't know how to integrate this one so far. And so the integration of this is going to be basically x, and if you plug upper minus lower, this is going to be 2 over 6, and this is going to be 2 over 4, which is exactly is equal to 1/3 and 1/2. So I will put that thing here so you can take a look at it. Yeah, these questions is usually we have in your true and false and the conceptual part of the exam, integrations. Mostly integration questions are there, and some of them, maybe one question is you really need to do some sort of U substitution or big integrations techniques. This question is again, I can do the 2 is very easily. So number 2 is you just write down this integral 2 to 5 f of x d of x 2 to 5. No, it's 2 to 9. It's 2 to 9. Yeah. I want to write it as a single integral. So the one property is I can always decompose my integral into 2 pieces. But I have to start in the same point. We have to break at the same point, and then you're going to start the other one. You see what I did basically? I took the first integral, I break this into 2 pieces. The point 5 is in between this 2 and 5th. You have to have this point has to be in between this thing. Otherwise you can't like break into something else. So 2 to 5, and then I write 5 to 9. So then addition sign is there. So if the point is in between, there is always addition sign. But now you see this integral and that integral is the same thing, and they will cancel out. So they going to cancel out. So this is going to cancel this, and the only thing we left with is 5 to 9 fx dx. How about that? That's all we need for this question. That was pretty easy, The second one is basically almost same. If I do one part, I will let you do the others. Question number 3. And this is basically 0 to 4 fx dx. I can write this one 0 to 1 because 0 to 1, the information of 0 to 1 is a given. And then I have to write 2 to 4. So 0 to 1, sorry, 1 to 4. And this is the 1 to 4 fx dx using the same property. 0 to 1, the integrate is 1. 0 to 4, the integrate is 7. So totally become 8. Again, I take this integral 0 to 4. I divide into 2 pieces, 0 to 1 and 1 to 4. 0 to 1 is given the value 1. 1 to 4, the given value 7. So to plug it there, you get 1 plus 7 is equal to 8. Okay, so that's pretty much like you can see this type of question in true and false or short answer, Let's see. Wow. Seriously? Okay, show that the first thing is what is FTC? Anyone can see what is the definition of FTC? A short form of something. Fundamental theorem of calculus. Maybe, yeah, that's close one. And this is a g of x is equal to secant square. The first thing is you want to verify, to compute the derivative and show that both derivatives are equal. So we're going to differentiate both the function and see what happens. If I differentiate fx is going to be 2 tangent of x and derivative of tangent x is secant square x. That is going to be the derivative of my first function. Derivative of g of x is going to be 2 times secant of x. And what is the derivative of secant x? Secant of x times tangent of x. Therefore, this is going to be 2 times tangent of x times secant square x. So you verify one thing, the derivative of f prime of x is equal to g prime of x. This is the verification. You want to verify your function f, the function g have same derivatives. But what if I use the fundamental theorem of calculus and I integrate these one? This identity, I integrate this identity with respect to x by using fundamental theorem. This is going to give me f of x because derivative of the function, the derivative of the antiderivative is give you function back. And this is going to give you g of x and plus some constant of integration. What it tell you? It tell you the function are same, only differ by a constant. The fx is nothing but is equal to gx, but different by a constant. And this is true. What is the fx? Tangent square x. What is the gx? Secant square x plus 1. They are same thing, because this is again is equal to tangent. This is my gx, and this is the tangent square x, and this is my fx. They only differ by a constant 1. So this is c is a constant, which is a 1. So fx and gx are only differ by a constant. So that is the conclusion of our statement. Okay, that was basically what is the tell you what is the definition of the antiderivative. Antiderivative is something is we want to recover back the derivative. You compute the derivative of the function, but you lose the function. You want your function back. So you integrate that function again. But when you integrate, you will lose some information. That information is constant. You always lose the constant information from the function. Okay, a rocket, 900 kilogram rocket, is released from a space station. It is burn the fuel, the rocket mass decreasing, and its velocity increasing. So many things are going on. Let v and be the velocity as a function of mass. Find the velocity when m is equal to this. If that is equal to that, assume this is equal to that. Okay, so what we need, what we have here, again FTC, so fundamental theorem of calculus, dv over dm is minus 50 m to the power minus 1/2. Okay, that is my df over dv over dm. So the differentiation of my velocity with respect to the mass. If I integrate with respect to the mass, with respect to m, so integrate with respect to m, I'm going to get Vm here, because the derivative is going to cancel out by the fundamental theorem of calculus. Integration going to cancel the derivative, I'm going to get V. Okay, V is also a function of m. Here, I'm going to be 50, I'm going to add 1 in the power, is going to become 1/2. That's how you compute the antiderivative. You add 1 in the power and then you multiply by the reciprocal of the power, which is the 2. You first add and then you multiply by reciprocal. But in a derivative, first you drop the constant and then you subtract 1. So these are the two different things between the integration and differentiation. I believe this is a minus 100 m minus 1. Oh, what is the constant of integration? Constant of integration. Now let's see, we're going to compute the constant. The information is this: V, if m is a 900, the V is a 0. So it means this is a 0
if m is a 900, 900 raised to power 1/2, what is that number? Wow, 1/2, 30. 30 times 100 minus 3000, oh, plus 3000. You see? Okay, if I plug that back, so Vm is going to be minus 100 m to the power 1/2 plus 3000. That is your velocity in term of mass. That's the velocity function in terms of mass. Is there anything they want to compute? Find the velocity when m is this. So they give you the mass. So you want to find the velocity when m is 729. Okay, that's good luck. I'm not gonna simplify this one, but I will let you use the calculator because this number is very... Yeah, I don't know what is the square root of 729. Anyone know? Square root of 729. Siri, what is the square root of 729? Oh, she didn't understand me at all.
The square root of 729 is 27.
Yeah, she did. She's getting better and better. Yeah. In the earlier days when I asked her, she always said, no, sorry Sadbir, I did not recognize your accent. Try again. Okay, so this is going to be minus 2700 plus 3000. Okay, please calculate this one, I'm kind of done with the calculation. Okay, this number is going to be, in your calculator. Okay, one last question before, one maybe two more. How about, oh, what is happening? Okay, yeah, this is my favorite question. Question number 4. This is always in your exam, sort of, most of the time. This is again a fundamental theorem of calculus, So the fundamental theorem of calculus, now I really gonna write down what is the fundamental theorem of calculus, FTC. The fundamental theorem of calculus tell you d over dx, integration from a to x, f of t, d of t is equal to f of x. This is sort of a form of fundamental theorem. Then I'm going to write down the general form of a fundamental theorem of calculus. So what is another form, which is a more general, which is a d over dx. If you have a function h of x and the function g of x instead of linear function in the limit, and then you are computing the f of t, d of t. So this one is a chain rule. So this is a f, the function g go inside, and then you multiply the derivative of g, and then minus the lower limit. You plug the lower limit into the integrand and then multiply by the derivative of the lower limit. These are the two fundamental theorem of calculus. The first one is basically the most basic form, which usually you might have seen in your class. The second one is the more general form, but you can see that this form can be derived from this form. If I take h is equal to a and g of x is equal to x, you see that I will plug x here, become f of x, derivative of x is a 1, and derivative of h is 0, this term go away. So you only get f of x. So this is a more general form of fundamental theorem of calculus, but this is a particular form of the fundamental theorem of calculus. When I choose my x, g of x is equal to x and h of x is equal to y. So this is important for this question. All of them, this will gives you the answer. So where is my pen? So let's compute this c. C is the most one, this look like the most challenging one. When I compute the derivative of the function d over dx of x square to x to the 4 and square root of t dt. So you see that if you know the fundamental theorem of calculus, you don't have to, no, there is a guy in the homework he was doing. He was computing the integration of this function first, and then plugging the upper and lower limit, and then simplifying everything, and then taking the differentiation. You know, if you don't know the fundamental theorem calculus, then that's what you have to do. But otherwise, it will give you the answer in one line. It will say f of x, f x to the 4 will go inside this function, is going to x to the 4, and then the derivative of this function goes here, which is a 4x cube, minus then this function go inside, x square, and then it is a derivatives go here, which is a 2x. That's all. That's all you need to do. You can simplify, but if you're not feeling like, that's fine. You know. So you can simplify because x to the 4 cancel out. Let's do it. It's just a one step. This is going to be x square 4 times x cube. This is going to be 2 times x. So this is going to be 4x to the 5 minus 2x square. So that is your fundamental. That is your derivative of the integrand by fundamental theorem of calculus. Otherwise, you have to integrate, plug upper and lower limit, and then do differentiation. You will get to that, you know. But theorem will give you a shortcut to compute. One more question. I think this question you have in the homework, I will go to the last one, integration. Is sort of, which one you want me to do here? You can note question number 6 is interesting. Sketch the graph of an increasing function f such that both the derivative and its antiderivative are decreasing. Have any idea how you do that? This is a very conceptual question, I believe. First one, yeah, this is like, you know, Brennan type of question where he tried to challenge your ability to do math. Make you think. So how you break down this question piece by piece? If the graph of the function, if the f is increasing, the graph of an increasing function, so f is increasing, it means its derivative is positive. One thing, you know. If the function is increasing, its derivative has to be positive. Second thing is, f prime is decreasing. You know, if f prime is decreasing, f prime of x is decreasing, it means f double prime of x is negative. Is that correct? If double prime is negative, it means the function is concave downward. So one thing is the function is concave downward. You know, one piece of information is f is concave downward. So one information. Second is, if the integration, the antiderivative is negative, it means function is below x-axis. Otherwise, you're adding, you know, the way you can make this thing is negative, because if it is above the x-axis, you always adding the area, you know. If the function is above the x-axis, you are adding these pieces all together. Because you are integrating from 0 to x, it means it's calculating the area from 0 to x. But if f of x is a positive, like suppose here, you know, this is x. So as the x is moving, you are adding more and more and more area. It means the function is increasing. The function is below f of x. Function is negative. You know. That's the two information I know. I think that's enough information. You know? So I can plot this function. Something like that. You know? Something like this. It's a concave downward and it's below the x-axis. Satisfy all the information. The concavity downward, it tells you that f prime of x is decreasing. It's below that. That will gives you that it is antiderivative or the area is decreasing and the function is also increasing. So I satisfy all the three conditions. Okay, one thing about the one last one I'm going to do is last question, and then I will say goodbye, and then you can enjoy your rest of stop day. What are you going to do today? Going to study or no study for tonight? Square minus 4x plus 3 dx. Okay, this function, I don't know how to compute the derivative of absolute value, or I don't know how to compute the antiderivative of absolute value. First, I want to write this function as a piecewise function, x square minus 4x plus 3. I want to write down this function as a piecewise function. How you do, you're going to do the line test again. So x square minus 4x plus 3, let's find the critical value of this function. Anyone know how to find the critical value of this function? Oh, it's going to be 3 times, so 3 and 1, so minus 3. Is that critical value? The factoring. So critical value is a 1 and the other critical value is a 3. If you plug 0, which is here, 0 is here. If you plug 0 and between 1, what is the value of this function is at 0? It's a positive. So it's a positive here. And 1 to 2, if you plug 2 here, that give you negative, that give you positive. This is a negative here. And if you plug 3 and above, so that's positive, give you positive here. Oh, okay, so the side was not clear. So now this is, it means 0 less than x less than 1 function is a positive. So absolute value of this function is gonna be same. But 1, 2, 3, negative, so I put the negative sign, the same function. And then 3 to 5, 3 to so on, but I just need 3 to 5 because 5 is the upper limit, is again positive. So I say x square minus 4x plus 3. Okay, we have a piecewise function. We want to integrate this piecewise function. Is going to be 0 to 1 plus 1 to 3 plus 3 to 5. And in this function is going to be here x square minus 4x plus 3, integrating with respect to x. This is going to be minus outside x square minus 4x plus 3 dx, and this is a positive x square minus 4x plus 3 dx. Okay, I have 4 minutes. I think I'm going to complete that thing in 4 minutes. So this is going to be x cubed divided by 3. This is going to be 2x square. This is going to be 3x upper limit minus lower limit. This is a minus sign. Is going to be x cubed minus 3 plus 2x square minus 3x 1 to 4. And this is the same damn thing, x cubed divided by 3 minus 2x square plus 3x, this time 5 to 3. Okay, wow. Now what we gonna do? Upper limit minus lower limit. This is a lot of calculation. Siri, can you do this? If I plug 1/3 minus 2 plus 3, this means 1/3 plus 1, which is basically 4/3. Oh no, really? I don't want to compute that one. 4 to the power 3. What is the 4 to the power 3? 60? 64. So what's your name? So Jean said 64. Okay. I didn't say that. And 416, that is a 32. And this number is 12. I think you can do these things, Or we're going to leave like that. If you plug 1, you get 1/3, which is you get a minus 1/3 now. If you plug 1, let's see, if you plug 1, you get this, but this is a negative sign, minus 4/3. Are you seriously? 5 to the power 3, 25, 125. So 125 divided by 3, minus 525, 50, 15. Why they don't let you use the calculator? It's I think it's abuse, doing something like that. No, I'll give up. Okay, so you can compute these little numbers. Add everything into the calculator. Hopefully, calculator tell you something. Which is the answer. So one thing I'm gonna make is when you do the exam, it is very important that you circle the final answer. So that is make the grading a little bit easier, and it's also sometimes helpful if you circle your answer, so we can find where to look at the. And I will wish you luck on Thursday on the finals, on your finals. Hopefully all you get A. And I will see you in Math 126 next semester, hopefully. And thank you very much for your attendance. You need it, I can give it to you. Yeah. You need this one? Okay, yes. Attach this thing so that it's copyright. No problem.